from experiments it is observed that when same amount of heat is supplied to various materials or different substances, the increase in temperature is different. That means if we take unit mass of each substance and supply them with same amount of heat, the change in temperature is going to be different for different substances. So that is why we specified this term as specific heat capacity or heat capacity, which will be now considered as the unit or main quantity with which we can estimate the value of how much heat should be supplied to a given material according to its mass. So what we can say about specific heat capacity is, or going in different direction, what we have said is the amount of heat, suppose delta Q is small amount of heat supplied to a material, so that will increase its temperature, right? So it will actually going to be dependent on what? Initially mass. So heat given to a body will initially be directly dependent on the mass of the body, because more the mass, more is going to be the heat absorbed by the body. Secondly, heat given is also directly proportional to change in temperature of the body. You supply more heat, it will undergo more change in temperature. Combining these two factors, the heat is proportional to m delta T. So we place a constant of proportionality called C, which is called specific heat capacity, C times m delta T. Okay, so this equation, usually I say this equation by what? Q is equal to mc theta or mc delta T. I generally write it sometimes mc theta, which I use in numericals, right? So what do, or how do we have to define C? If I put heat to be delta Q only and m is equal to 1 unit mass, either 1 kg or 1 gram, and delta T is 1 degree Celsius or 1 Kelvin. So we can define specific heat capacity in this way, that specific heat capacity is equal to heat given to a unit mass of body such that its temperature increases by, or such that its temperature changes by 1 degree Celsius. Or when there is a change in temperature of unit, when there is a unit change in temperature of unit mass of a substance, then heat given to a body is equal to its specific heat capacity. Phrase it any ways you like it. Now, what could be the SI unit? SI unit of C, this is specific heat capacity, is C is heat upon mass into change in temperature. So it could be calorie per mass per kg per degree Celsius, or calorie, no, I have to use gram with calorie, right? And with joules I'll be using kg. So calorie per gram per degree Celsius. And since there is no numerical change when we change the value from Celsius to Kelvin, so this would be the CGS unit, and SI unit would be joules per kg per Kelvin, right? These are the SI units in CGS and SI system. Now we know that 1 calorie is equal to 4.18 joules. Okay, so if I have to find out specific heat of water, specific heat capacity of water, it will be what? C is equal to heat, okay, 1 calorie per gram per degree Celsius, or converting it with kg, 1 calorie per kg. Per kg means divided by 1000 or multiplied by 1000. This kg is already on the denominator side. That means here I'll be having 1000, right? And per degree per Kelvin. So Kelvin minus 1. Now changing calorie to joules, 1000 into 4.18 joules per kg Kelvin. I prefer writing it this way, it's more convenient. So this becomes 4180 joules per kg Kelvin, or in numericals we take it as 4200 joules per kg Kelvin. That means the physical meaning of this term is specific heat capacity of water is 4200 joules per kg per Kelvin. That means we would require 4200 joules of heat to change 1 kg mass temperature by 1 Kelvin or by 1 degree Celsius. This is the physical significance of term specific heat capacity, and we also call it as heat capacity.